In the diagram below, AB is parallel to PQ, AP is equal to PD, and DR is equal to RC. Prove that BC is parallel to QR. Now, BC is a side of triangle BCD. So let's make this triangle red. According to the midpoint theorem, in order to prove that BC is parallel to QR, we need to show that Q is the midpoint of side DB and R is the midpoint of side DC. The diagram shows us that R is the midpoint of DC because of these two lines over here and over here. But we don't know if Q is the midpoint of DB, so we need to find this first. Let's make our diagram black again. Side DB sits on triangle ABD, so let's make this triangle blue. The diagram shows us that AP is the same length as PD and that PQ is parallel to AB. So now we can make some statements. So we can say in triangle ABD, AP is equal to PD. This information has been given to us in the diagram, so we use given as our reason. We also know that AB is parallel to PQ. And again, we use given as our reason. The converse midpoint theorem states that the line drawn through the midpoint of one side of a triangle parallel to another bisects the third. Here, P is the midpoint of side AD and PQ runs parallel to AB, which means that Q must be the midpoint of side DB, which means that DQ must be the same length as QB. And as our reason, we say converse midpoint theorem. On our diagram, let's put 3 lines on DQ and 3 lines on QB to show that they are equal in length. Now we can make our diagram black again. Now we know that Q is the midpoint of DB, so we can prove that BC is parallel to QR. BC lies in triangle BCD. So once again, let's make this triangle red. We can use the midpoint theorem. So we can say in triangle BCD, the diagram tells us that DR is equal to RC. And we can use given as our reason. We have also just proven that DQ is equal to QB. We don't have to prove this again. So as our reason, we simply say proven above. Q is the midpoint of DB and R is the midpoint of DC. So according to the midpoint theorem, BC must be parallel to QR. And as our reason, we say midpoint theorem.